column reference functions. Okay. So the column reference, let me create a into. So we'll see the column reference functions. Inside the column reference function, we'll see column. Okay, I'll create this as a one. First and column reference, we'll create it as a two. This we'll create it as a three. Okay, this is column and column reference. So column name returns a column object from a given column name, and column is an alias for the column. They are primarily way to refer to data frame column inside the transformation expressions. So the syntax to utilize this, before the syntax, we'll see how it works in visualizations. Okay, so let me show you that. Let's say this one. So if we imported the function like column, and in bracket we provide the column name. So in this case, column name is any of the data frame. It returns the column object. There are a Pythonic way to extract the name, which is if you have defined the data frame, then we can provide in square bracket as a column name, and it will return again a column object, but it is bounded to the specific column, and it is not optimized as per the Spark application is. But this function column is optimized. If you want to add some literals into the column, then we can utilize these uh, functions to add literals. So it will return a new column expressions. Again, if you want to add conditions, you can add that too. If you if you have added a condition in this way, it will return the Boolean value, which is a true or false. Okay. So let's see its implementation in real use cases. So let me show you. I have prepared one case for you. Okay, I have created the data. Let's see the data, how it looks like. Okay, so in the data, we do have the ID, name, and score. In ID, name, and score, we do have the three entries here. First one is for Alice, second one is for Bob, and third one is for Carol. So we'll utilize this data frame to see the use cases of this column and columns. So now this data frame is ready. Now we can see like what are the different methods we can use. So first method we have seen methods. One we have seen is using column in bracket column name. Okay, so I have to use this f, since we have imported it as a f. Then we have to import. Okay, import PySpark SQL function as f. Okay, so we have to utilize the f dot column. Okay, so let's see how it can be implemented. Let's see, we will select df dot select. Then bracket, let's provide the column f dot column. It is providing address suggestions, but we'll type it manually because we have to be known about what are the things is going on, and we should have the hands on while we write, because some of the companies has not implemented the AI thoroughly, since it's a like a free version that I am using, so that's why it is enabled, and it is showing me the suggestion for this. So let's see from this method what are we are getting. So with the select, to select the name and the score, we have utilized this column functionality. So it is taking those rows. There are the different method that to select the column. We have the to method to using df, which is df column, and here we provide the column name, which is and actually it shows the identical agent. It shows identical results as above. Okay, so let's see, select and bracket df, then we can provide the name here. Okay, and then what are the second, df in square bracket, there is a score, then complete the bracket, then type it as a show. Both would give the same result. So this is a second method to retrieve the column. Okay, and like we can use the columns for the expression that we have mentioned earlier, which is this one. So this will return the expression. So if there are the aggregation, we can add literals in to provide the aggregations. Okay, here we'll yeah, do the simple cases like column inside set expressions. So let's see. Let me select those column. In the select, we can utilize f dot column side name comma f dot column inside we'll add a score, and we'll multiply the score by 10% increase. So to increase the 10%, we have to multiply it by the 1.1. Let's see how it shows multiply score. Okay, so you can see like we received this 105 instead of 95.5 for the Alice, and for the Bob it is 90.2 instead of 82.0. Okay, so since here we see the expression itself, so we can alias it to the different name. Okay, so we'll see that alias in down the line. So meanwhile we'll keep it as it is. Okay, so let's say now we have written uh, did the some aggregations, which is multiplication here. So let's see another thing here, which is a conditional, like which returns the boolean value into the column. Okay, so let's copy the same thing, and in the score itself, instead of multiplication, we can add a comparison operator. If the score is greater than 90, then it should show. Okay, now here you go. We get the boolean value true, false, true, false. Okay, so let's see the score as well here. So you get to see the score as well, so it will be better to understand. Now there you go. 95.5 is greater than 90, and that's why it returned the true. 82 is less than 90, that's why it returned false. Likewise, we can get the Boolean expression in the derived column. Okay, so this is all about the column. So prefer tip here to use a f dot column over this second method. Use the method one, which is very much optimized and reusable functions. Okay, so avoid using this second method, which is df.name. It is kind of a pandas verified assessing method. Like in pandas, we have to assess it this way. There are another ways to assess the column, which can be like we can assess it df.name. This way also we can see the return this name. Okay, okay. Sorry, we can add it as a show. Maybe this is not accepted here. Let me see. We have to. Okay, we can directly pass the name as in we pass it in a SQL instead of mentioning anything. We can pass it as like this. Okay. So this method can be utilized, but if you want to do aggregation, want to derive some expression, then we should use a column functions here. So it doesn't bind to a specific data frame. So making the code easier to compose for the JVM objects, which Spark utilizes. Okay, so this is all about the column referencing for the columns. So either we can use a call or column. So actually call is alias for the column. So both are the same. Okay, for more you can see there is a API docs Databricks guide here for this function. You can come and see here. So if you click on this normal function column, it shows how we can are able to get those data using this function. So there is some like top level they have mentioned. So but I'm mentioning and telling you in a very detailed manner, so you can easily understood this. And this is how it works in the production environment as well, actually in the development. So we can utilize the different method. There are the company standards and practices they built. So based on that, we can use our code, and we can refactor our code according to their standard practices. Okay, so now we'll move to the next functions, which is a SQL expression as a column. Okay, so like we have seen previously, which is the expression as a column. Let me show you that in the column reference functions. We do have second one is a SQL expressions. So there are many more functions. It is not mentioned in this table, but we are gonna see those because those are also the important functions. Okay, so let me create the topic here, which is expressions. Sorry, this is supposed to be. second point here, SQL expressions. So this expression parses a SQL string expression and returns the column. This lets you write a arbitrary SQL style logic inside a select or with column and filter, including case when functions call arithmetic and sub expressions without switching to the SQL context itself. So let's see how it works. Before that, let me show you one table where the different ways of implementation can be seen. Okay, so let's see here. Now here you go. So inside the expression function, we can pass two different column addition. Okay, this is equivalent to column A plus column B. It returns the numeric column. Here we can pass the Boolean expressions, comparison operators here. So, this is a conditional operation. In expression, if column A value is greater than 90, then it should return the Boolean value, which is true or false, which is equivalent to column A greater than 90 that we have seen earlier. In another way, if you want to do the conditional logic using a case when statement, like we used to do it in the SQL, here we can pass in expression case when a column A is greater than 0, column A value is greater than 0, then it should return 1, else it should return the 0. So it is similar in case of a PySpark Pythonic way. We can utilize this when column is A is greater than 1, 0, then it should return 1, otherwise it should return 0. So it returns the integer column because we have mentioned the 0 and 1 into the query. Okay, so there is another expression we can see here, expression upper name. So this is actually the SQL like query that we can return inside expression expr functions. Okay, so and it is similar equivalent Python or PySpark which f dot upper. Again, this is a SQL function that can be imported from PySpark SQL function libraries. And again, we can pass the column inside it. It would return the string value in the uppercase. Again, there is another which is a between function between and. So here it is asking like if a between 10 and 20, okay, then it should return the Boolean value which is true or false. If a is between 10 and 20, it will return true. If it is not between 10 and 20, it will return the false. And the similar equivalent case can be implemented by Spark or Python logic, which is column A dot between 10 comma 20. So the equivalent PySpark it's look way similar or way simple for the implementation, and the possibly it is very much readable, and any programming background student can understand this logic. But in left side, it is a similar kind of SQL based logic we can implement inside EXPR functions. Okay, so the purpose of this function is only to implement the SQL style logic inside the functions. Okay, so let's see the implementation in the Databricks notebook. So here we utilize same data frame, or we can create another one. Okay, so I have modified some columns in it. Okay, let's see how it looks like using a df.show. So there you go. So name, math, and science. So there is a name of student and their subjects. Inside subject, we received their scores or their percentile they have received, or we can consider as the marks they have received in that specific subjects. Okay, so we'll implement the logic here. So what are the logic we can implement here? So let me try to select these columns using and add the expressions. Okay, so now we have selected this df.select. As you know, df.select is similar to select star from employee table. So this is a similar case. Inside select, okay. So we'll implement the select the columns using a f.column. Column inside that we'll pass the name. Okay, give the comma. Again, use the expression to add the math and science, both of the let's calculate the total marks received by the each candidate or each student using the expr. Then I will use expr in bracket, and then we can pass that column. Okay, I will pass this math plus science. So now we have passed this as a expression. Then we have to add some name to it. Okay, so I will alias it. So this is alias. We see these aliases in depth. Basically, alias is to give the namings to the derived columns. Okay, so I will add it as a total. Okay, so another expression can be derived like we seen in the example table. So another example can be like expr in bracket. So we can implement the case when logic here. So let's see, if the mark is greater than or equal to 19, then its rating should be the A. If the when math marks is greater than or equal to 75, then its rating should be B. Else it is C. Okay. So we'll implement this condition as a grade. Okay. So let's write it in SQL way. So we can write case. So I am formatting this in a good manner so you can understand it easily. If math is greater than equal to 90, then so now I'm using a multi-line uh, string here. We can implement the multi-line. Okay, multi-line string here. Let me add the enter. Okay, then we should rate it as a give the grade as a A. Okay, then next condition will be like when math is greater than or equal to 75, then it should get a rating as a or a grade as a B. Or else we provide the grade C. Okay, now we have provided this entire thing. After the case has been initiated, okay, we have to end this statement. Okay, so now we have ended this statement. Now we should give some aliases to it. I can give the alias as a grade here. Okay, so now grade has been decided. We have created that. Let's like give the weightage to the math and science, and then calculate the weighted values or weighted grades here. Okay, so let's again import this take this function dot expr. Inside it, we can calculate the weighted average, which can aggregation can be provided like 40% to math plus, and science would get 60%. It is so weighted average. Okay, then we'll see the data frame how it looks like. Okay, so now our code is ready. We can ready to execute this. There you go. So in the name, we can see Alice. Their total marks in both subject math and science, and they are graded. So since the in the math, Alice got more than 90, then his grade becomes A. And the weighted average, which is calculated based on this formula, which is math goes at 40% and science goes for the 60%. It is calculated to 86.20. Okay. So you can see in the total, we are getting null values for Carol. So actually, if you see, Carol does not have the total value as a null. Okay, so since null cannot be sum, so that's why it returns the null. In aggregation, we should handle the null properly. So null handling we'll see in another lecture. But if you see, the null cannot be added, multiplied, aggregated with any other column. So if you deal with the null cell, then it will again return the null value. Okay, null is nothing. That's why it does not get considered in any of the operation. That's why Carl get total value as a null and weighted as well as it is as a null. Okay, so before this, we should have implemented some values here to handle the null, or we can implement some zero or average value inside the null. Okay, so this is all about the EXPR. The key concept here is EXPR is especially powerful for porting SQL queries into the PySpark without rewriting the every clauses. Let's say there are the migration work going on and we don't want to port the each and every query into the PySpark code. Then we can use the EXPR functionality to copy and paste the query into this. Okay, and you can use it to leverage SQL case when between in and function syntax directly into it. Okay, now we'll move to the next topic. So for normal functions, uh, specific to this column reference function, there is the column. Second function is a EXPR. Okay,